Hello Berliners and people of the internet. Thank you for joining us in this remote edition of Elixir Berlin. I hope that you and your family are safe and you're ready to enjoy the next following holidays. As you know, we as Elixir community in Berlin, we are running this user group since 2013, and in this scarce situations, you are again the only reason that this thing happens. So thank you all. I just want to take a moment to thank you and appreciate that. And I hope that you have a really great event today. Here are the places that you can reach us, and we are introducing yet another social platform to join, and this time is Discord, and it's somehow related to this streaming. Just a quite quick introduction how today's live streaming is going to work. If you are watching this live stream, it means that you join half of the party, but don't forget to also join the Discord app. That's the place that the cool kids are. Join the server, click on the left in the April Meetup channel, and you can join the conversation, ask questions at the end of the talk, and so on. I should also mention that it's best if you install the Discord app, so make sure you don't miss that. By the way, did you know that this course is using Elixir in their backend? Maybe it's a good reason to give them a try. So I'll give you 3 minutes to join this course if you like, and then we can all hang out there. So for the agenda today, we have 2 talks. I thank them both in advance. Georgina managed to pre-record the talk yesterday, since we were not sure if we can broadcast this with a high quality today to you. And however, she will be available at the end of the talk to answer your questions. And this live streaming, of course, wouldn't be happen without Lucas' help and his experience. He helped us to bootstrap this live stream in less than a week. And he's here today as well, is going to give us a lightning talk. Before I hand it over to the speakers, I just want to mention that we are all new to this streaming, so thank you all for bearing with us, and I hope that you forgive us if there is any shortage, and do keep us updated with your feedbacks. So now we are going to start the first talk.
I would like to talk about some concepts that keep my brain active since a while now. They refer to how to build your system in such a way that it will be scalable, but also at the same time, it would not require much maintenance. This presentation was meant in the beginning for a slightly different group of people with more or less experience in Erlang OTP, so please bear with me today. My name is Grigor Georgina. I'm a staff engineer in Solaris Bank. I joined this year in January. You can reach me via Twitter, so please feel free to contact me if you have any questions or if you would like to share some thoughts. My domain context is in the last 12 years. If I were to summarize, I would say I worked in four projects that shaped the way I think, work, and approach things. They also offer me a ground for drawing some patterns and being able to share some thoughts with you guys today. The first one I would mention was in pharmaceutical industry. It was a backend integration system for aggregating documents and their metadata. I was involved in reshaping it in such a way that it would allow 100 concurrent search requests with feedback time in less than 2 seconds. The second project I would mention was in the home automation domain. It was an event-driven based system, and it was also the first one that showed me how or what happens if you hit the maximum int values in the databases. The third project I would like to mention is one that changed my way of working and changed my way of thinking. After 10 years of working with Microsoft solutions, I switched to Elixir, working in this project, which was designed for messaging as a chat and also event streaming, where we had up to 350,000 active connections during peak times, and we used to process over 30 million messages per hour. Today, I work in banking, where reliability and fault-tolerant systems are the key and the focus. So the agenda for today would be to mainly present some concrete design and practices ideas towards concurrency, resiliency, scalability, and distribution. But first, I would like to go back to the basics and present an ideal world, or maybe the beginning of all the projects, where maybe you just have to, or having just stateless APIs that just fetch data can be enough, or maybe when you don't have unreliable, less performant dependencies, or maybe you don't have to adapt the workload due to variable load, or the same fixed amount of jobs can be always triggered, or maybe also when the old trick of using the database for caching your data is more than enough and managing the state. Or maybe I see this pattern more and more in people thinking, saying that it is just enough to throw more nodes at it and it should be enough for supporting extra load. But the question I want to go back to with this mindset is, do we always improve the throughput by adding multiple nodes? And this is a question I want to focus on because it depends. Let's say we are still in the context of simple stateless applications, then yes, it shall work, but up to a point. This approach can also get very expensive depending where do you deploy your nodes. When this topic is raised and when people approach me with this kind of scaling their applications or expecting that the applications I work on be able to do just that, I usually tend to check the computational power of each node. How many cores does the node have? How many CPU do we use? What type of activities are carried on? Is the application taking advantage of all the cores? If the answer is no, then just throwing more nodes at it will move the needle just a bit. For leveraging the CPU efficiently, I've been down the road of implementing multi-threaded applications, and we all know it is hard. Thread safety is difficult to achieve, especially in the context of mutating state. All OOP languages do that. But this became much more easier in functional programming languages where state is just transformed. This simplifies the things a lot, making it more easy to achieve, for example, concurrency and be able to take advantage of multiple cores of a machine in using the CPU in more efficient ways. So, therefore, talking about concurrency, I think it's really critical to make the difference of real concurrency and parallel tasks. And concurrency just refers to the ability of splitting your work in multiple independent processes so that the execution of more than one process is being processed in overlapping time periods. This does not necessarily mean that they will be all processed at the same time. But yeah, we will talk about that later. What I want to also mention, and which, yeah, I use a lot in the back of my head, is going back to an article when WhatsApp published. They managed to have 3 million connections on a single node. To me, this sounds amazing and it is huge. I don't know how to represent 3 million connections, so this would have been nicer to have presented in person. The most close thing I could think of was to search for a picture where 3 million people will be put together and to see at least how this looks like. So you can see here, this is a picture with a beach in Rio when they said the 3 million people are here. So yeah, this idea is crazy. And I'm always thinking about this, how they managed to achieve this when I'm designing the systems I'm working with, or I'm discussing with my colleagues about the systems we are working with, because I have the feeling that we have the tendency of designing microservices and just adding new nodes, and we forget that maybe less is more, and maybe with less we can achieve more. So I keep always this in my mind and trying to scale down. And in the next slides, I would like to talk about some ideas and things that you can do for achieving this. So in the ideal world, I presented things that, for which you don't have to come up with complex solutions in building your systems. But what happens when the use cases change? What happens if the concurrency you have to support increases, or the number of the events you have to build increases as well? And I think the most variable thing nowadays is a variable load depending on of the user's behavior. So depending on domain and depending on who your users are, you may have peaks during certain hours during the day where it is critical to handle more load in comparison to the other periods, or maybe during the year if you're a sport system and you have these events happening from time to time. So my first advice would be in approaching this, because I've seen this too often. I worked with projects, or I've been thrown at projects that in the beginning they were just it was just critical for them to work, but after a while the use cases changed. They had more users, they became successful, and then they had to be we have to rethink the way we built them. So the first step is always measure the expected, under the expected load, everything. Put metrics, load test it, and also focus on testing your system resiliency. But I will also talk about this. It's really important to act only after you do this, because maybe you're lucky and you don't have to do anything. Maybe your system scales well, maybe your system behaves well under the new requirements. So just adjusting based on, or maybe you don't have to adjust. If that is not the case, then it is critical to have an iterative process in which you just adjust based on the concrete extracted numbers and reiterate until you have the numbers and the measurements you're happy with. So I want to talk about how you can identify if your system scales well and if you have to take more measurements or if you can keep it as it is. In my view, a perfect scalable system is one that has a fixed marginal cost to adding additional users or capacity. I tend to think that scalability is closely related to maintainability, and it seems to be often overlooked that people spend only a short of time developing the applications and the rest of time maintaining them. So I see the scalability as being the characteristic of a system or a model or function that describes its capability to cope and perform well under an increased or expanding workload or scope. So I would say that a system that scales well will be able to maintain or even increase its level of performance or efficiency, even if the load or a larger operational tasks are demanded. Why is it important to have your system scalable? As the business grows, the main objective is to continue to meet market demands. So the trouble is, demands are never static. They shift as people's interest and taste change, and as resources flow in and out of availability. So if you want to stay competitive under these circumstances, you have to be able to change what you're doing to fill the needs and wants the customers have at some point. So scalability also matters because growth in business means you're working with more customers, data, and resources. And if you don't have a way to handle these increases, you can lose efficiency or the quality of your services or products can suffer. This can lead to poor customer relations and lower business reputation. So therefore, the way I would see it, at least with Erlang OTP, and this changed also in my brain when I started working with it, is something that Joe Armstrong said. Before switching to Erlang OTP, we used to have one server handling millions of sessions or tens of thousands of sessions. But what Erlang OTP offers is to have 2 million web servers handling one session each. And I would say this is the key. Once you manage to understand this, then it becomes a lot easier for designing your system in such a way to achieve this. Otherwise, and I think in the beginning is a lot easier to just reuse the same concepts you're used to and put them here also in building your Elixir applications in such a way that they will look like .NET, Java, or Ruby-like. But once you understand these concepts, then I think you basically grasped the key. The key to this is just, a game changer. If there is a software error and the software crashes, then you don't have 2 million sessions depending on this crash or being affected by it. You will just have one session being affected, and the rest can continue without even noticing. And this was the key of the project I worked with previously, and I think this is also the key big software providers or application providers like WhatsApp take advantage of. So let's talk about Erlang OTP. I know most of you are already experienced, but as I mentioned in the beginning, this presentation was not necessarily meant only for experienced Elixir developers, but also for less experienced. So I will just briefly go through this. As I mentioned, Erlang main strength support is for concurrency. It has a small but powerful set of primitives to create processes and communicate among them. These processes are the primary means to structure an Erlang application. They are neither operating system processes nor threads, but lightweighted processes, both in terms of memory and CPU utilization, that are scheduled by Beam. The most critical part of those is that they don't share state with each other. Therefore, many processes can be created without degrading performance. Tens of thousands of those can be added to a node and can be executed simultaneously. Also, I think it's critical to pass this fear in having so many processes on a node, and in order to be able to leverage the CPU capabilities and bring the concurrency to the next level. Though all concurrency is explicit in Erlang, processes communicate using message passing instead of shared variables, which removes the need for explicit locks, making the things a lot easier. Also, by using these concepts, it's a lot easier to facilitate building distributed applications. RPC and distributed tasks are built in Erlang Elixir abstractions and allow communication using Elixir term without any additional serialization or deserialization. Making things a lot more easier. And of course, the supervision tree that we all know, which helps a lot in how crashes impact each other, or how you design a fault tolerance system in such a way that your processes will recover from different failures. So not this yet, Okay, I would like to talk about some practices or ideas that we used in our systems, and hopefully we will also use in the next ones that helped us scale and also obtain this fault tolerance that we all want. With the increased and the different load, it was critical to be able to spawn dynamic processes. And what helped us a lot was to have them named in such a way that it would be easier to build on top of them means for checks and be able to find them and check their state in case we needed to do some introspections. Then, yeah, to cluster or not to cluster, this all depends on the domain. I would say I've seen applications where it was possible to build stateless applications, but by also leveraging parts of the OTP. But I've also seen applications that were built on top of Erlang capability clustering with success. Decide to with clustering, it's really important to be aware of all the failures that happen around those. So not fail, but also latency given by a network communication. So group processes which have to communicate with each other along the same node increase the performance a lot. Also, moving forward, designing your supervision trees in such a way that they will take advantage of all the CPU cores is also key. If you design your system in such a way that you will have hundreds of thousands of processes on one node, it's critical to have your supervision trees designed in such a way that they will find your processes and manage them performantly in such a way that you will have them batched and be able to crash them quickly. Also, it is important to define your communication channels. So not only grouping the processes on the same nodes, but also be aware of your processes that have to communicate across nodes, but also about how you communicate with other services. These, for sure, can bring pain or can bring flexibility in how you scale your system. And yeah, I think I can talk only about those. Also, I want to talk about caching. There was a previous discussion in this Meetup group about caching solutions and if you should use some external system for it or if you should use internal one like in memory or in your Gen servers. I've seen them both work. It all depends again on your domain. It can bring benefits, but also disadvantages, both. Caching your data outside the system for sure will decouple the need to maintain your state during crashes or redeployments. Maybe you will just have to maintain or design your expiration time to leave of your keys. But building the caching inside the system can bring you power in being able to stay up when everything fails around you, when the database is down, or maybe when you cannot communicate with third-party system. Caching data for a while may help a lot into being able to stay up a bit longer, or at least to be able to leverage some of the system capabilities. Like, for example, in the project, We used to allow various customers communicate with each other. It was critical for us to be able, in times of pressure, in times of failures, to allow at least the mainstreams for people to talk. So even if we were not able to back up our messages or store them for future retrieval, at least we were able to allow the main core functionalities to work, which I would say, yeah, it was critical. Okay, so let's move next. Persistence as a backup for recovery, I would say it is also critical. Because it's not only about failures that I mentioned previously, it is also about scenarios when you have to deploy and maybe do some maintenance of your application. So this is key. So even if you decide to cache in order to have a more resilient system and more performant one, persisting your data is key for being able to back up and recover from any situation. Idempotent actions are also again key. If, for example, you have a fleet of multi-service of microservices which have to communicate with each other, is really tough to build reliability and the retries and to make sure the messages are not lost. So if you decide to use the external systems like, for example, SQS, Kafka, or maybe other messaging systems, or even Elixir for that, it's easier to provide at least once delivery. So having idempotent actions is key for cases when your message happened something with it and it was requeued and you will have to process it second or maybe multiple times. Then moving forward for allowing or designing resilient systems, having exponential backup retries becomes critical in terms of failures. Maybe your system becomes, but maybe a third-party system does not. And if it is loaded from multiple places, not only from your side, retrying very aggressively can make things worse. So having exponential backup retries helps a lot. Resiliency to dependencies failures is also a critical one. And for this, there was a previous slide when I mentioned it is critical to have your system tested, not only under load for measuring the metrics, how your system will behave, but also what is critical is to also check and do some chaos monkeys like Netflix has for checking how does your system behave in case your database is down, because maintenance times can happen or temporary network for sure can happen anytime. So it is critical to make sure your nodes don't fail, your application does not restart in a loop or did not get restarted in a loop, but you manage to cope with those. Also, moving in the direction of retries and connections, it is critical not to put load on your caching solution or your database, which can become a bottleneck. And for this, the landscape around Erlang, Elixir come with Pullboy, which helps a lot. Then throttling can be used, and back pressure or load shedding, they all come together and can help again in critical situations when can provide you the only means for coping with aggressive consumers or clients in uncertain times. As I mentioned, measuring everything is really critical so that you can adapt. In the past, it helped a lot to have measurements from OTP, from the beam, in terms of knowing the number of your processes, the number of your message boxes, and how many processes, how many messages your processes can cope with. This can give you a really good hint if you have bottlenecks at the process level, if some of your processes are slow and have to be optimized, if your message queues start queuing and never get clear up. Also, run queue length, port count, garbage collection count, and reduction count helped us a lot in dive times when we had issues in understanding how the system behaves. But I would say that not only the beam measurements are critical, but also having your own custom measurements for different things your system does. Okay. So I would like to end this talk with a couple of more things that help with the awareness on how to design your system and how to protect yourself. Don't trust the network. It can fail. Even if you deploy your systems in cloud providers, things can fail. Don't trust your dependencies and third parties. Don't trust your surrounding infrastructure. Don't think there is no latency or that the bandwidth is unlimited. Don't think the topology cannot change. And don't be afraid to write tons of logs. These are all great advices. I put them here not only for you, but also for me to remind myself about those. Those are things that we tend to forget, and those are the things, the hidden things that in the end can hit you hard if you are not prepared. And yeah, maybe I will do a presentation only about those. There was a thing, slide, I thought I had it at the end. Yes, this one. Maybe what is also key to end this meeting with a scalable, reliable system is not necessarily performant, and I think this is key in when presenting the capabilities of your system to your stakeholders. Your stakeholders may not be very technical, so it can be very difficult for them to understand all the concepts that we talked about today. So it's also critical for make them aware that there are always trade-offs in having either scalable, reliable systems or very performant. So if you want to have, for example, a very reliable system, it might bring back your measurements in the performance. But if you make your stakeholders being aware of those, then some parameters can get or can get to the state of being better accepted It's just about being transparent of things we can do and things we cannot. But yeah, I just don't want to leave this note here. I just don't want to end this in the sad note. I've seen, and we can also go back to the WhatsApp applications and say that they do scale, they are performant. Maybe some messages are not sent, and then it's always a trade-off, and it's always about transparency and understanding. Just not to have high hopes that everything can be achieved. So I will share these slides with you, and here you can see. Hello, hi everyone. Can you hear me? Awesome. The presentation ended slowly, so we are apologizing for being slow. Yeah, it is a learning process also for us. So feel free to contact me for asking questions, also now, but also after this meetup. Let me check. Okay, so we have a question, and I will repeat it for the streaming. The question is, how would you best design supervision trees according to the CPU cores a system uses? Are there libraries that have to do that in a dynamic environment, or is it more of a pick your server and write code according to it? This is a great question. Thank you for it. I'm not aware of libraries. What we did, we took a practice or an approach that, to my understanding, is also approached by other teams in other projects. There is a way in finding the number of schedulers the beam can have, depending on the number of the cores the machine has on which your application runs, and based on that you can leverage, and then you can design in such a way that your supervision trees can be partitioned, and then when you design or spawn your processes, you can set them under certain partitions of these schedulers. This way allows you to split them, so in case you have tens of thousands of like failures or introspections. If you join the April meetup, you can also ask questions directly there, but feel free to also write here. Yeah, exactly. I've seen this solution implemented in multiple places, so maybe we can start writing a library and expose it at the community level. Um, yeah. But for sure, exactly what you mentioned, this was the key in supporting various load during the day. We had customers that were active during half of the day, during the night more active, and during the day we did not have that many. So it was critical for us to be able to spawn dynamically processes and have them supervised in such a manner that they will not impact other processes in case they failed, but we also had processes that, it was critical for closing everything in case they crashed. So I'm not sure you can design a very generic approach on how to design your supervision trees, which can apply to all domains, because it all depends on how your business is and how your gen servers are created, what your business is, what's your dependencies. But at least, we can learn from each other what practices each one of us are using and trying to leverage those. Do you have any other questions? Thank you. Then, I will stop.
Thank you, Georgina. So the next talk is by Lucas. I'm going to hand over the streaming to Lucas.
Ah, okay, all right. Um, so I was just curious if you can hear me or not, and if it's working. Uh, Hi everyone. I'm doing a short, basically 5. Um, so okay, maybe one last try from my side. I hope it works now. Oh, still twice? And now, I think now it should be better. Sorry, I'm I'm actually doing this for the first time. Now it should be good. So maybe back to my lightning talk because I don't want to use all the time for things. So what I'm really curious about for a long time now is actually dot files. So you might notice from configuring your own computer, and I've become really interested in them. And since then, I've been following two things mainly. One, there's a lot of awesome lists on GitHub, and I follow some, and then I even also entered mine dot files in there, and then I looked at many other people's dot files and different kinds of shells and all kinds of things. And in the past, I have been also been doing presentations on different shells. I have been using the fish shell for some time, but recently I basically came back to Bash, and I came back to love it as it is. And if you don't know what dot files are, I encourage you to check out the awesome list of dot files, and also obviously also check out somebody else's dot files. They're basically the um, shareable version of somebody's computer configuration or terminal configuration, therefore, right? And I have built up mine in a way that you can configure your Mac as well as your complete terminal environment. And maybe tour you through a few gems that I find quite useful and helpful in my dot files, and maybe encourage you to fork them, build your own, and share them, and contribute to this whole dot file community, because I think it's really interesting to see how people set up their computer, how they set up their workplace, and everything. Um, so one thing that I find really important when working with the terminal, and I basically this is the first thing I tell everybody, is this thing. When I hit a key and I keep hitting it, and you see I'm hitting the J now, and it kind of repeats really, really fast, and that's really nice. And there is one thing. So if you look at the keyboard preferences in your Mac, you will see key repeat fast, right? And every time I set up a new Mac, I have been doing this and pulling this lever to the right, and the delay until repeat too short, right? This might make a small difference for some, but if it's on the default setting, which is somewhere here, right, the difference is quite staggering. If I now hit the key, it's taking ages until it actually, you know, repeats itself. And that's really important when you, for example, use backspace to delete something, um, and switch those to the right and make those really, really fast. But then, so what you want to have a repeatable setup too, and that's where I think the makefile and the dot file setup that I have built comes into place really handy. So if I look at my makefile and my dot files repository, and that's also, I think, one thing I would like to share, and I would like to know how you are setting up your Macs and your computer, is the defaults from macOS. So what I've been just doing with the system settings is actually possible to set as a default. And Mac has this really nice defaults write command where you can set global defaults for your Mac computer. For example, I can set it to int2, and that's gonna make my key repeat really, really fast. So if I just execute that, that will set up a system setting, make my key repeat really, really fast again. I can even set it much faster to 1, and then the key repeat is just blazingly fast, and it's even faster. So I would not recommend this. So 2 is just usually fine. And I wanted to have this every time I set up a new Mac and a new computer, right? So I have kind of designed this make file so that I have a section in there that describes how I just going to mention the sections in the make file that I have set up so far, and that can be used to set up any Mac computer. So the big default section sets up a couple of macOS system settings here, and I have documented each one of them, as well as setting up how my dock behaves and the globals and whatnot. But I use this makefile also not only to set up my computer with defaults. I also use it to set up certain programs. For example, I have Vim, and there I have a Vim section where I basically install Vim itself and then also take care of the plugins. So whenever I update Vim or change something in my dotfiles in Vim, the only thing I have to write is make Vim or make Vim dash plugins, and then I'm basically going to be fine and be set up. So just a glimpse on the idea I had there with the whole makefile, and basically if I do make all, I can set up a new computer from scratch. I can basically just download this repository, hit make all, and it's gonna install all the software I need, set up the fonts, set up the bash shell and all the environments, set up the defaults, and even does some security settings for the machine I'm working on. So far I have not seen anything similar other than machine enrollment and provisioning of Mac computers itself. So I'm really curious how you're setting up your computer and your system, and be it you're a Ruby, Elixir, or other developer in general, if you're working with the terminal, you're probably gonna be setting it up in some way. So I'm curious, what do you think about my dot files? What do you think about the setup? And I'll be panning out for now and handing back over to Milad. Thank you for watching this small intro to dot files and the world of dot files that allow you to set up your bash environment.
So thank you one more time for joining us. I hope that you have a great holidays and stay safe. Ciao. We can still hang out in the Discourse, of course.